text it.
Welcome aboard the International Space Station. I want you to wave goodbye to all your friends and family down there on Earth. Now let's say you come in from a long day spacewalking and want to get some sleep. Now if you just close your eyes and drift it off, that is exactly what you'd be doing. You'd be drifting around the cabin, bumping into the other astronauts and switches. So to prevent this from happening, each astronaut gets their very own sleep restraint unit. Alright, Xavier, let's get you tucked into bed. Can you put one on through here? And one on this side. Now the last strap is for heads just to keep it from bobbing up and down on that as you sleep, but we don't have to worry about that one. But, how does that feel? Well, if you think that's good, let's still put you up here at the top one, right? It's gonna feel a lot better for you, I promise. No, I'm just kidding, you don't have to worry. In microgravity, there is no up, down, east, west, floor, or ceiling. So we can have one astronaut here, one up here, one along this wall, and one right where I'm standing, and they would all feel the exact same. Like here on Earth, nobody should feel comfortable sleeping strapped to a wall for 8 hours. So let's just get you tucked from here. And could you go ahead and please have a seat on the dual cycle ergometer? You can grab the handles and the foot pedals and start exercising. Now, one of the negative side effects about living in space is that microgravity actually reduces our muscle mass and bone density. It's like an accelerated aging process. So to counteract this effect, our astronauts must work out 2 hours a day, 7 days a week. Expedition Crew 58, which is aboard the station right now, uses very similar machines to this ergometer, as well as a treadmill and an advanced resistance exercise device that should be playing in the video behind me. Now the purpose of this machine is to help our astronauts actually lift weights while in a weightless environment. Alright Xavier, you have an hour and 58 more minutes to go. You got this. I'm just kidding, that's enough we're going to have for you today. Good job, astronaut. Could you go ahead and stand right here for a minute? Now ladies and gentlemen, it is the moment we have all been waiting for. The waste hygiene compartment, or as we like to call it, the space toilet. Now on the station, there is no gravity, so things work a little different. First we push this button here and that starts the suction. Now your number 2 goes right into here, but it has a very small hole. So you have to make sure that you have good aim and that you let go in the right direction. Whenever you're ready to go, well, hey, you can just go. Now we can't have any water in our toilets, so we rely on suction to do the job of what gravity does for us here on Earth. The solid waste gets sucked into a container and we later get rid of it. But we save the liquid waste. Now the liquid waste goes right into here. Just remember, water is a valuable commodity aboard the station, so we must save it all. Like I said, it's going to go in here. Oh, but it's going to come out right here. That is right, ladies and gentlemen. We drink it. Again. And again. And you guessed it, guys. Again. So, how's that for a refreshment? That's pretty tasty, huh? Space life is glamorous, yo. So not only will recycling water in a closed-loop system help us get further into space, but we are actually using this process here on Earth right now. Not just for recycling, but also for purifying to help us save lives here on Earth. Alright, you stay right where you are. I'm just going to go to the other side of you. So hopefully we haven't killed your appetite, because you are going to want to wash your hands before you eat. But what are we missing? Wash your hands, what do you do? Yeah, we don't have any water or a sink. Because like I said, water is very precious aboard the station. So our astronauts use antibacterial wipes for their hands and larger wipes for the body. And if our astronauts do want to just wash their hair, well, NASA has provided them with powder shampoo. We can easily just rub into the scalp. Alright, let's float on over here to the galley area. This is where you and your fellow astronauts will be floating around. Some upside down, some right side up. Probably talking about your day and preparing your meals. Well, these days, our astronauts have a wide variety of delicious beverages and meals to choose from just by adding water. And it's actually the same kind of water we just discussed. Now, we can't let go of what we're using or else it will float away. So, All of our food packaging, well, it has Velcro on it, along with all of our walls and surfaces. So that in case of an emergency, if you just let go of your meal, it's most likely going to make a mess in the cabin. Your crew members will be upset. All you have to do is strap it to the wall. You can go ahead and deal with that emergency. Whenever you're done, well, your chicken and rice is waiting on you. Alrighty, so we demonstrated sleeping, exercising, going to the bathroom, personal hygiene, and food preparation. But the International Space Station isn't just a place to live. It is a space laboratory where we conduct scientific research that is impossible to do here on Earth. So with your help, we're going to do some of this research, okay? Alright, let's head back this way. What I would like you to do is when you put your back along this wall for me, please, with your arms down by your side. Because what I'm going to do is just give you a quick body scan, okay? The thing about the scan, though, before I start, you have to know, it is going to hurt just a little bit, and unfortunately, it also leaves a very small permanent mark somewhere on your body. Unfortunately, we never know where this mark is going to end up, so you do have to make sure to check yourself when you get back to Earth, okay? Alright. Hey, I'm just messing with you. You're going to be perfectly fine. Alright, well, this scan's loading. I'm going to ask that you please head down the stairs back to your seat on Earth, because I want you to see what we're going to do with your body scan. Audience members, another round of applause, please. Now, here on Earth, gravity keeps this delicious beverage inside. So let's take gravity away just to see what would happen. As you can see, surface tension becomes the dominant force. And when two blobs of water merge into each other, they are going to form a larger blob of water because physics appears to behave very different in microgravity. And when that water comes into contact, with an absorptive surface like that towel, a wicking action will powerfully suck it up like a sponge would here on Earth. Alright, I think that body scan is ready to come up on the big board. Here we get to see how our astronauts react to living in microgravity, while the fluids in the body will slowly move up from the arms and the legs. Now this is going to cause the faces to become puffy and the legs to become thin. The astronauts aboard the International Space Station have given it a highly scientific name. They decided to call it chicken legs. Also, you will lose bone calcium and your spine is going to grow up to 2 inches. Also, in microgravity, guys, your heart it slowly starts to shrink. But don't worry, when you come back down here to Earth, it should gradually return back to its normal size. But with the calcium loss and many other things, recovery is going to be difficult. That's why our astronauts are willing test subjects to help us understand how reduced gravity has the effect on the distant space travels. In other words, guys, before we make our way to Mars, we are going to have to find a way to prevent osteoporosis. Now, biological processes isn't the only thing that's different in microgravity because chemical reactions behave very different as well. So, let's go ahead and take a look at the simple candle flame. Wait a moment. Perfect, there we go. Let's go ahead and take a look at the simple candle flame here on Earth. You see the shape that the flame takes. If you've ever lit a candle here on Earth, you should recognize the shape that the flame forms because it makes a teardrop. But have you ever wondered why? Well, the flame makes hot air so it rises. Now this is going to cause cooler air to rush in and take its place. This process is called convection, and it's why flames in the way that they do here on Earth, round at the bottom and pointing at the top. But in microgravity, hot air can't rise, so there is no convection because there is no air. So what does this mean? As you can see, the flame is going to burn in a round globe shape instead of what we're used to here on Earth. Check this out. It burns more completely, much cleaner, and more efficiently. Having a laboratory in microgravity gives us the opportunity to find out why it does this, and how can we do that back here on Earth. This is very important for future engine designs. Also, our microgravity research on the physics of combustion will help reduce pollution and give us more efficient fuels. So as you can see, guys, the microgravity environment of the International Space Station, it is a great place to be doing experiments that we can't necessarily do when we're here on Earth. Let's try another two. Let's try combining large amounts of lead and tin here on Earth. Well, lead is heavier, so it sinks to the bottom, while the tin will stay on top. These two, they're like oil and water. They just don't be mixed together. But in microgravity, these two can easily be mixed to create a molten alloy that is used all kinds of, like electronic parts for our mobile devices or computers. This is very easy to make. You just can't do it on the contract. Now, the microgravity environment of the ISS is also like a unique laboratory for medical research and development. It's an ignorant scientist here on Earth, studying a nasty bug or even just a disease. He cells to be researching. Only problem is, with Earth's gravity, these cells are not going to be able to grow large outside of the human body without their own weight crushing them. But in microgravity, cells fly. They grow bigger, they grow faster, and they grow in 3 dimensions. This is a huge medical breakthrough. So we can generate large quantities of these cells, and our scientists can study the data back here on Earth. So in the coming years, we should see many amazing advancements in disease control, genetics, biochemistry, and organ transplants, all thanks to the International Space Station. So who knows what we'll discover next? Well, as you've seen here today, the International Space Station is helping to better our lives here on Earth right now, but it's what it's offering in our future, which is just even more exciting. Now, the ISS is just the stepping stone off of this planet beyond our Earth's orbit. To the moon. To asteroids. To our next destination, the red planet of Mars. And of course, even to the stars beyond. Now, who knows, ladies and gentlemen, our next research explorers could be sitting with us in our audience today. Alrighty, can I have volunteer come back up? Xavier, if I'm not mistaken, can you make your way back up the stairs? I want to give you a gift for being my volunteer today. Alrighty, so I have a few things that I want to give you, but first off, I'm going to start with a picture of astronaut Xavier, who was part of Expedition Crew 16 and 17. He spent 3 months aboard the International Space Station and performed a 7-hour spacewalk. I just want to give you this, it's just a NASA sheet, just in case if you want to do any exploring on your own. And I am happy to say you are going to go home with your very own bottle of recycled urine. That is all for you, my friend. Ladies and gentlemen, one last round of applause, please.
Woo, Xavier!
Alrighty, guys, I want to thank you very much for joining me at Living in Space. You can experience more of what's happening aboard the station with the exhibit behind you. And also, while you're here, do not forget to check out Independence Plaza, because we are the only place on Earth with the 747 and shuttle on top display. So don't miss out, guys. Thank you very much.